Okay, so when you are starting to figure out trigonometry, what you need to do is think of it like if you were, say, a plumber and you went to a house to fix something, you wouldn't be able to fix a pipe if you didn't have, say, a wrench. Or, there may be some circumstances where you need a hammer or a screwdriver or all of these things. So you can be as clever as you like, but if you don't have the right tools, you can't do the job. And it's exactly the same with trigonometry. There's certain tools that you need. And then once you know how to use each of those tools in each circumstance, then trigonometry becomes much easier. So what I want to do is just go through the tools one by one. And some of them are going to be ones that you've been using since you started. So those are the very basic tools. And that's your sine, cos, tan, right? So this all started way back in ancient Egypt, was actually Pythagoras. But let's say that you had the pyramids and you wanted to work out the height of the pyramids. Well, the pyramid is kind of a difficult shape, right? But what we know is that when something's in the sun, it casts a shadow. And so this would cast a shadow here. And let's just do the ray of light. Now, if you were to have a stick, because you can't measure the height of a pyramid that easily, or if it's a tall building, going to the top of the building, or even the height of a tree. But what you could do is you could take a 1 meter long stick and you could measure the shadow that the stick casts. So let's say this is a 1 meter long stick and it casts a 1.5 meter long shadow. Then you simply go, okay, well, let me go from the middle of the pyramid. So if we were to draw this down, if I was to kind of go along here, that would then I could then measure out the shadow, and let's say the shadow was, let's make it the maths easy. Let's say we had a 150 meter long shadow. Then what we know is that we have a triangle here, which is similar. And why is it similar? Because the angle that that's cast by the sun is the same. So the angle of elevation. So that's something we need to know. Angle of elevation. Okay, so these similar triangles help us to know then that if this is 1.5 to 150, then this height here would be in the same ratio. And so we just know intuitively that it would be 100 meters, because 100 over 150 is equal to 1 over 1.5. Okay, so that's the usefulness of trig, is to be able to measure heights of buildings, heights of trees. And so now we go into how the ancient Greeks then took the idea of this these similar triangles and angles, and they figured out that they all have the same ratio. So then we come to the first bit of our, well, let's go to the very beginning, but I'm not going to go into great detail on this. Pythagoras, his theorem was, if you have a right angle triangle these two sides, A and B. If I square them both, I get the same as the square of the long side. So in other words, the square of the two small sides is equal to the square of the large side. And the large side is called the hypotenuse. So this is your first one, and you have to put in your, and of course this you'll see in geometry as well as trigonometry. So Pythagoras. Okay, so that's the basic one. But then when they really get you onto trig, you learn some old hippie caught another hippie tripping on acid, or SOH CAH TOA. And then that gives us our another, so this was like your hammer. Now you've got like a wrench, and the wrench is this sin, cos, tan. And this is for right angled triangles. So if I was to take this right angled triangle and I was to then, let's make it sine, let's call it sine, cos and tan. Then I have here, and so that angle there, the opposite is the O, the adjacent is the B, and of course the hypotenuse is the C. And so I have sine equals opposite over hypotenuse. So this would be the A over the C. Or the, let's make the C, let's call it H, because that's hypotenuse. And so the cos would be the adjacent. So the adjacent to this angle is B. This should all be, and then opposite over adjacent, tripping on acid. Okay, let's just change. So this, when we look at this reference angle, this would be opposite. So we could actually say O, right? Opposite, that one. Opposite, so that would be O. And then B would be adjacent. We could actually, shouldn't really have called this A, but this would be adjacent. Let's do it as a capital A. That's O over A. So this is your kind of first tool that you were given. Pretty simple. But then what they did is they said, well, let's take this idea that you have your ratios. So in other words, if you have an angle, the ratios are always going to be the same as long as it's a right angle triangle. So the ratios will depend on that angle, and the angle will depend on the ratio. So you can always figure something out if you have two of the things, right? So now what we could do is we could take coordinates. So we could add an hour point. So now we're going to take our trigonometry and we're going to add it to a, so X and let's do Y. And so if we have a point on this graph, and now this is where you would have learned your cast diagram. Okay, and actually a lot of people hit Matric and actually do quite well in Matric without understanding really what the cast diagram is. They just learn it. But let's understand it, because to understand it would make it then easier to learn. It's easier to learn something that you understand. So what I could do is I could take this point X and Y and I drop it down to the X axis. And then this here would be, this distance here would be X. And if I went to the Y axis, this would then be Y. And now if I go over here, along here, let's do this in yellow, I then have a hypotenuse. And so if I have an angle to this axis, theta, I can simply, because I know now if this is perpendicular, this is a right angle, I have a right angle triangle. This allows me then to work out a whole lot of things in the Cartesian plane. So let's have a look at it. So sine, cos, tan, and we'll do the green angle. So what's opposite here is a y, and the j, and the hypotenuse is an h. And what do we have? Cos is adjacent, so that's x over h. Now what I'm noticing in this first thing, y is in our cast diagram, this is always the a. Well, we can see it because all are positive. So tripping on acid, so opposite is y, and adjacent is x. Okay, so that's the first thing we learn when we get to the cast diagrams of trigonometry, is that everything in the first quadrant is positive. And we actually go around anti-clockwise. It's not like bearing where you go clockwise. You go anti-clockwise. And so here we hit 90 degrees. This is 180. This is 270. And this is 360. And this is why when you get general solutions, you always add K360. Because if I go around in a circle on this thing, I end up in the same place. So this, if I went from 360, if I add another 360, I just go back there. So we always say play plus K360. And if this was 2 theta, then technically I divide my 360 by 2 and it becomes 180. So we'll get there later. Okay, so now what we could do is we could then say, okay, let me plot a point in this quadrant here. I'm not going to do all 4 quadrants because I feel like this is something you may already know. What do you think?
Yeah. The cost diagram I didn't find too difficult
Not
to
an issue.
understand.
Okay.
I think my issue was more so when it came to solving like the solutions and
Okay, so we'll finish this off then over here. So you understand this tool, so that's great. And then we'll go hypotenuse. And we notice that the x is negative here. And the y is positive. And so, of course, cast. So I'll just write the C and the A and the S and the T. We see that sine here is positive. Well, if we look here, yes, sine, what's positive? Y and H, right? Those are the positive things. So Y, H, positive, sine. The X is negative, and that is why these two are going to be negative, because the X's are negative. That's rather this. Negative, negative, and the sign would be positive. And then, of course, here negative, negative, and that's why the tan is negative, because these are both negative. All right, so that's the cast diagram. And then were you fine with your double angle formulas? And
Oh no, may you please go through that?
okay. So the next tool then we're going to get now, we're getting more complicated. How about your sine, cos, and tan rule, the non-right angle triangles?
I'm not going to lie, I forgot those.
Okay, I'm going to go through those. So this is all for a right angle triangle. Now we go to non-right angle triangles. Actually, let me do this. Then I can take screenshots. Okay, now this I wanted to actually be visual for us, because when you get the question in the paper, I want you to look for, and I'm going to be using this phrase a lot, sides hugging an angle. Sides hugging an angle. But we'll get there. First, I want to just do the basic thing, which is that it's all based on little a being opposite to the big A, and then B being opposite to little b, and then C being opposite to little c. And so this formula, the first one is the sine formula. So A over sine A equals B over sine B. I'm going to probably rush through this bit because I feel like the sine rule may be the simplest, but C over sine C. But so let's get a non-right angle triangle. And let's say that this is, do you have your calculator with you? 30.
Yes.
What's that? Make it 125. And then this will be 25, right?
Mm-hmm.
Okay, they won't give us that, right? Let's say they give you that, and let's say they give you this 10. Okay, so what we do is we assign an A and a B. So let's call this, like, if this was called G, I'm just gonna, in pencil, write this as A and A, because I see that I've got a side and an opposite angle. That's what I'm looking for in the sine rule. The sine rule, I'm looking for a side and an opposite angle. And then any of the other things. It could be a side or an angle anywhere else, doesn't matter. So if I could already say that this is 25. But I don't necessarily need it to work out maybe, let's say they asked you what this was X, right? Let's say I said, what is the X? And so I know the angle, so I'm going to call this B. And so then this becomes little b in my formula. And so I'm going to use this in my formula. Now, of course, this seems easy when you're looking at it now, but where it gets hard is they give you these questions with like loads of different lines, and the more lines and angles they add, the harder it gets. But what I want you to do is I want you to get some erasable highlighters. I'm going to send you the Take a Lot link afterwards. And what this does, I'm gonna because this actually allows me to use erasable highlight. Now the reason I want to use erasable is because sometimes if you highlight stuff in one of these complicated drawings, you end up with, like, you highlight that and then another line and then another question asks you this, and you eventually have so much highlight that you don't know what's going on anymore. So, but if this was all white and then I say, well, let me want to highlight, well, I can then highlight the stuff that I know that they've given me, and then you sort of start to see, oh, okay, the pink is opposite the pink, and so then you go, okay, that's the shape I'm looking for a sine graph. The sine rule, and so we go. And then I want to say, okay, I want to use this formula. And if I'm looking for the angle, I must put sine B. So this could also be written as sine B over B equals sine A over A, with the A's on the top. And if I'm trying to find the angle, put the sine A on the top and the sine B on the top, because then you don't have to like manipulate later. So it's like, what am I looking for? If I'm looking for the side, let me put this formula with the side on the top, because then I don't have to switch the x later to the top. It's already at the top. So it's x over sine 30 equals A, 10 over sine 125. And then I simply, the sine 30, when it goes to the other side, goes to the top. So it's 10 sine 30. So this will be 5, because sine 30 is a half, we know from our special angle. Let's show you that I moved that there. And this is sine rule here. And 10 sine 30 over sine 125, you put in your calculator, you get an answer. Okay, do you want to put it into your calculator? I don't mind if you don't have an answer.
I don't know if I'm doing it right, because I'm getting 16.
Yeah.
Which I don't think.
Yeah. Oh, wait. You should get an angle. Oh, no, that's okay. Yes, because this is 25. So if this 30 is a larger angle than 25, this should be bigger than 10. So that's fine.
Oh, okay.
So what do we get? 16 points?
0.4.
Okay. 16.04. Now, what I want to do is just talk a little bit briefly about when you get to university, if you do science. If you do the Cambridge syllabus, they always say 3 significant figures is the default, but in university, your significant figures is the least accurate measurement that you're given. So they'll if they say that this is 10, they'll often say 10.0. And so when they're giving you 10.0, but let's say they give you 10.0 and 12, your most accurate is 12 significant figures, so you'd 2 significant figures, so you'd give 2. If they put 10.0, you give 3. And so a 0.0 is actually significant. 10 at university could be 10.4 rounded down, or 9.6 rounded up. It's a weird thing. If they put the point, that makes it significant. And then 10.0. So 10 point makes the 10 significant, 10.0 makes the 0 significant. So I would give my answer as 16.0. So that's just something to keep in mind when you get there. Because it's one of the things, when you write your first test, you come back and they give you 60 and you realize you could have gotten 75 if you got your significant figures right. And that's the way they teach you back in the first term. So rather than getting punished, hopefully you remember that. Okay, so that's the first one. Now what I want to do is so we've got the sine rule. We use the more complicated rule, which I hope is going to actually become quite easy once we think of it as you are looking. What are you looking for? You're always looking in this rule, you'll see this rule here. A squared equals B squared plus C squared minus 2 BC cos A. And what I want to do is I want us to think of this not as a formula that we have to remember, but I want us to think of this visually. I want us to think of this visually. And I know that if you can make the shift from thinking of this visually rather than like learning, and it's like I'm getting a formula and it's an abstract concept, but I know I get it if I just plug it into the formula. But rather if you think of it visually, all of your questions and your trig questions are going to become much easier because you see it and you learn visually, because we're not numbers people. Like before there were numbers, there was just trees and mammoths, you know. That's what we remembered. We remembered like, oh, you know, we're not programmed evolutionary really to learn numbers and letters. So now if we start to think of things visually, I think it'll be easier to remember. So that what do I mean by that? Well, what are we looking for to get? So let's highlight the things that are in this formula. So we've got an A and an A, and then we've got little b, little c. Okay. So now, if I imagine that this triangle was part of a much larger diagram with loads of lines and that was confusing me, if I simply just take my erasable highlighters and put them on the things I'm looking for, what I find is that it's actually always what you're looking for is two sides hugging an angle. So the sine rule, you look for a side and an opposite angle. But here it's two sides hugging an angle. So what is the shape I'm looking for? I'm looking for this. Okay, and so as we kind of learn more and practice more, you'll start to see the shape, and I'll say, and then if you say, I'm not sure what to do here, I'll go, okay, let's highlight this, highlight that, because they've given us, and given that. And then I'll say, okay, well, look, we've got two sides hugging an angle. And that means we can get this side here. Okay. So we're going to do an example without, obviously, the crazy lines and everything. The other thing we're looking for is the three sides. If you get the three sides, you can get the angle. Because I had that A. Okay. But more often than not, it's two sides hugging an angle. So I'm going to make this 4, I'm going to make this 10, and I'm going to make this 40. And we could call this, it's because they often, it'll be like G, E, F, so it won't be like obvious. It could even be like a, you know, in the diagram, it may not be letters in order. That's the other thing. So let's do it with its letters not in order. So it could be P and say R. But it doesn't matter, because what we do, and we can imagine there were lots of lines, but if we can see what we're given and we do that, that, and that, we go, oh, two sides hugging an angle. Okay, it's obvious here because there's only one triangle. Imagine there's lots of lines, it's much more complicated. But now the second bit is I want to say, rather than get confused with the formula, I want us to start looking at the form and thinking of it as, okay, this side squared, the one that we're looking for, PR squared, because I've got two sides hugging an angle, the opposite side, this PR squared, is equal to, and I want us to go little side squared plus other side, so not little side squared, sorry, one side squared plus the other side squared minus 2 times the one side squared times the other side squared, not squared, sorry, just 2 times the side times this side, cos of the angle. Okay, now when you first do it, if you're not too familiar with it, you're going to probably do this. And this is fine. But when you get a bit quicker, you're just going to start to go like the way I did, which is that side squared plus that side squared minus 2, that side, cos of the angle. And then becomes like so easy. But initially what you'll go is, okay, so this PR, you'll actually make a note in this formula here. Okay, so you'll do the colors. You'll go in pink, I've got the A and the opposite side A. So that's that and that. And then we can go, that's the B. So that'll be there and there. And that's the C. There and there. And so you can just like plug them all into the formula. But I prefer to think of it as, just think visually. Okay. So I'll say that one more time. If you have a non-right angled triangle and you have two sides hugging an angle, the side opposite that angle is equal to the little side squared, sorry, not, it's equal to the side squared that you're given, plus the other side squared, minus 2 times those two sides squared, cos of the angle that's opposite to the side you're looking for. Okay, so when we start to approach these trigonometry questions, I'm going to be highlighting stuff. And so very important to get that those highlighters. I'm going to stop it there because I see we're running out of time.